video, we'll take a closer look at the Results tabs. The example I'm using is for a tube fin evaporator with multiple circuits and a sample file that comes with the program. Results for other heat exchanger types are similar, but will vary, and you can find additional details and information in the help file. The General tab displays the overall parameters for the heat exchanger. The first item is heat loads, including total, sensible, and latent loads, and a breakdown of the refrigerant, liquid, vapor, and two-phase loads. Next is the refrigerant charge, again broken into each phase, and the rate of condensate removal. Note that CoilDesigner does not account for condensate or frost accumulation. Refrigerant and airflow rates are next, followed by refrigerant and air side pressure drops. The program solves for outlet conditions, and average values are listed. Note that the average refrigeration saturation delta is used to indicate superheat or subcooling. A negative value indicates subcooling. A positive value is used for superheat, as with this evaporator example. The next section provides details about the coil's heat transfer, including the heat transfer coefficients. These are calculated based on the selected correlations and correction factors, if utilized. Refrigerant phase distribution provides a breakdown of the proportion of tubes containing either liquid, two-phase, or refrigerant vapor. Lastly, heat exchanger material, dimensions, and cost are displayed. These are all calculated using the inputs set in the new Coil Wizard and Edit Parameters area of the program. If we move to the tube's results on the pull-down menu, this displays a table with the mass flow rate, the latent, sensible, and total heat load, average heat transfer coefficient, Reynolds number, refrigerant mass flux, and tube condensate for each and every tube. Inlet and outlet streams provides a summary of the inlet and outlet conditions for each of the circuits in the heat exchanger. The next few options on the pull-down menu show the air temperature, refrigerant pressure, refrigerant temperature, refrigerant quality, air relative humidity, and condensate for each tube and each segment. Note that you can transpose these results to allow for easier viewing, depending on the number of tubes and segments you may have. The Results Tabbed View tab repeats information from the main results view, but uses tabs to display the results rather than the pull-down menu option. The Plots tab provides multiple options to visually review the results. Graphs can be displayed as a line or a bar chart. These plots can be particularly useful in identifying which circuits and which tubes are contributing the most to the heat load, and which tubes could potentially be eliminated. The 3D view provides a visual of the complete coil geometry, as well as the refrigerant temperatures inside the tubes. Lastly, the tube end plots is another visual tool to review key coil characteristics, such as heat load for each tube. When results are exported to Excel, two tabs are generated. The first tab is labeled as Inputs and is a summary of all the parameters used to analyze the coil, including the selected correlations and any correction factors used. The second tab is the Results and will look very similar to the General tab in the main Results viewing pane.